Hello and welcome back. Today's Soflex lesson for math is on comparing decimals. So it's going to be very similar to comparing whole numbers. So if you were with us for our previous lesson, this should be no problem at all. So we're going to follow a couple of the same rules when we compare. So as you can see here, I've already rewritten the numbers vertically. So instead of trying to compare them horizontally, where it's kind of hard to look back and forth and match everything up, I like to write the numbers up and down. So here you can see we have the whole numbers, which in this case there are none because we're working with decimals. And then we have our decimal point. It's very important to line up your decimal points. Tenths, hundredths, and thousands. So we line up our place values just as if, let's pretend that our number was 352 and 167, no decimals. We'd line it up the exact same way. And the same way, we're going to start at the left and work to the right. So we have no whole numbers. Decimals are lined up, that's important. And then we're going to look, is 3/10 greater than 1/10? Yes, it is. And same as with the whole numbers, we don't have to look any further. Once we get to the first one that there's a discrepancy, meaning a difference, well, 3/10 is greater than 1/10, which means our 0 and 352 thousandths is greater than 0 and 167 thousandths. As we work through these, it's very important, like we did our word form earlier. I really like you should really practice reading the numbers each time. Don't just compare them and say 0.352. So take the extra time, practice reading them, because if you can read the numbers, you can write them. And that's going to be important when we get to fractions as well. Because if you can read a fraction, you can write it as a decimal. If you can read a decimal, you can write it as a fraction. So it kind of works both ways. So that's kind of good for a future lesson. So let's do another comparison where we use some different amounts of place values to compare. Okay, let's look at our second example we have for you. So we have 0 and 8/10 compared to 0 and 146 thousandths. So many times students also look at these and they say, oh, I see 3 numbers on the right. 3 numbers has to be way bigger than just one number. Not realizing, once again, the place value and what numbers are in each of those place values. So just like we did with the whole numbers, we're going to do that with decimals too. So I'm going to fill in some placeholders. So I'm going to put some big zeros in here. So now when we're comparing from left to right, it should be a little bit easier to make sure everything's lined up. And then also make sure we're comparing tenths to tenths, hundreds, thousandths, thousandths. So in this case, wholes are the same, decimals the same. All right, so even though we only have one number, so 8/10 is the same as 800 thousandths. So 8/10 is greater than 1/10. So just because it only has 2 numbers here, the values of those 2 numbers compared to the value of the first 2 numbers on the right, the 0.8 or the 0 and 800, I'm sorry, the 0 and 8/10 is greater than the 0 and 1/10. So when we're comparing here, we're really only looking at this section, and that's okay, because these we didn't have to worry about because we just had our first difference. So 0 and 8/10 is greater than 0 and 146 thousandths. All right, let's do another example where there's some zeros in the decimal places, because that's also a point of confusion a lot of times. Okay, take a look at this example. So we have 0 and 4/10 on the left, and then we have 0 and 4/100ths. 0 and 4,000ths on the right. So when we look at this, we might be saying once again, oh, it looks like 400 compared to 4. But remember, if we use our place values, it makes it very clear that these are actually the same value. So this is going to be an equal sign for this one. Remember, we can put in our big placeholders, big zeros here. Okay, so we have 400, so 0, 0, decimal, decimal, 4, 4, 0, 0, 0, 0. So these are actually the exact same value. So this is our equal sign here. So they always like to put these on tests just to make sure you do understand place value. So here's an example. So if you really line it up vertically and you fill in those placeholders, you can see that it is the exact same everywhere you look. If it's the same everywhere you look, it's definitely an equal amount. Okay. All right, and let's do one last example with some different types of zeros to try to compare. Another type of tricky question they like to put on tests is this one, where we have all the same numbers. We have zeros and sevens. They're just arranged differently and obviously have different place values. So our first number is 0 and 7/100ths compared to 0 and 7/10ths. So as we look here, so we have the same number, same decimal, and then here we have a 7. I'm once again going to fill in the big place value. So 70 or 7/10ths is greater than 0.7 or 7/100ths. So in this case, even though it only has up here two numbers, 0 and a 7, and this one has three numbers, 0, 0, 7, according to place values, the one with 2 is actually a greater amount. So 0 and 7/100ths is less than 0 and 7/10ths. So just kind of make sure you can see the difference there and see how they try to trick you with the place values. They really want to make sure you understand each of the place values when you compare. All right, one final example before we move into showing you a decimal game you can play. Here we have a whole number with a decimal compared to just a decimal. And I would think it would be kind of a simple question, but a lot of times, once again, instead of looking at place values, people just look at the digits. So if they see a 9 or an 8, they say, oh, that's a way bigger number, and they just pick it without thinking. But as we lined them up here, anytime you have a whole number compared to a decimal, the whole number is always bigger. And in this case, we're going to kind of think of some money. So this one over here would be like $2.04, and this one would be like, well, 98 cents, and then a little bit more of a penny, which we don't have. But once again, lining up by place value, you can see that the 2 is greater than 0. We don't have to even worry about decimals in this case, because we're just comparing the whole numbers like first grade, 2 to 0. Pretty easy. So 2 is greater than the 0.9. So let's take a look at a new game that you could play. It's the exact same as the whole number comparison path game, but this one is going to be using specifically decimals. So let's take a look at what that game board and what that looks like. So if you were with us for the whole number path game, it's the exact same rules and everything. You're going to create your little path with 5 sections on it from least to greatest. You'll see that represented. Your game board's kind of in blue. And this is in the back of your math resource book, the template as well, or just draw it on a whiteboard. And then what you're going to do is you're going to use some dice. And each dice is going to be a different color, and that's going to represent the different place values. So in this case, our blue is going to represent the 10ths place value. Our green dice is going to represent the 100ths place value. And then the reddish will represent the 1000ths place value. That way when you roll the dice, you can't rearrange it to kind of cheat and make sure you have it the way you want it. So what you're going to do is you're going to roll your 3 dice all at the same time, and then you're going to order them up. And what you're going to do is take turns. You and your partner each have your own game board, and you're going to put it where you think it should go from least to greatest. So if I'm just going to kind of make up some numbers, what I may have rolled, just so you can kind of see how it goes. So let's say that I rolled, let's just say all 4s, just so we can understand how it looks. So that's kind of in the middle. So I'm going to go ahead and put it in the middle. So 0 and 444 thousandths. I'd also work on reading them correctly when you play this game, because that is going to help you in the long run as well, instead of just rolling and writing. Kind of think as well you go. Okay, another roll, let's say I had a 0 and 1, 2, 3. Okay, and another roll was a little bit greater, 0 and 714 thousandths. Okay, so as you go, your job is to fill out all 5 before your partner does, and here's how you would maybe lose a turn. So if my roll was this, so let's say I rolled a 5 for the 10ths, a 2, and a 0, because remember these are 10-sided dice, so they have the digits 0 through 9, so you could roll a 0. Alright, I lined them up, and my decimal amount would be 0 and 520 thousandths. Notice how the only place that would go would be right in here. Well, we don't have a space on our path for that. So that means that you lost your turn. So now your partner is going to go on their board. So that is a way that you could, where someone will not win if you don't strategically put these in the right spot. So you're working on ordering them, comparing them, reading them, and writing them the correct ways in this game. And the other rule is that you can't erase. So once you put a number on here and your turn's over, you can't erase it say, oops, I actually made a mistake. And make sure you and your partner are checking each other to make sure that you're actually putting them in the right order. Because you wouldn't want to have your partner put 0.832 or 0 and 832 thousandths right here. That doesn't make sense. So you have to make sure that they're actually doing the path correctly. So feel free to ask any questions, and I'm more than happy to answer those or clarify the game. The game board and game directions are in the back of your resource book. There's also some practice questions in the workbook or the resource book as well, with some answers for comparing decimals. We'll see you on the next episode of Soflex Math.